This teachable moment will address the question of whether spike-form fibrillation potentials and positive sharp wave fibrillation potentials have the same or different significance. There are multiple morphologies of fibrillation potentials. The two classic morphologies are spike form and positive sharp wave form, or sometimes referred to positive sharp waves in the literature. You can see in the slide the visual image of the spike and positive waveform. Here's a small triphasic spike fibrillation potential, and here's a predominantly positive waveform fibrillation potential. And as you note, based on the repeated firing of both of these, they fire in a regular firing pattern. So they can both be distinguished as fibrillation potentials occurring from a denervated muscle fiber based on the firing pattern. However, the question that's raised is, do these two different morphologies have differences in significance? And there's some debate in the literature. There is some literature that suggests that positive sharp waves occur earlier in a denervating process, whereas spike form fibrillation potentials form later. Some literature suggests that these are more common in certain diseases, such as myopathies versus neurogenic diseases. But really, the morphology doesn't necessarily reflect the disease state so much as where the recording electrode is in relation to where the fibrillation potential is being generated. So if you look here, here's a schematic of how a fibrillation potential is, or any action potential for that matter, is generated. And if the site of generation is right here along the muscle fiber, and the action potential propagates along the muscle fiber, the electrical field that is generated outside of the fiber or extracellularly is really a triphasic field. It has a positive field, then a negative field, and then a positive field. And that electrical field is going to propagate along the fiber in both directions from the site of generation. Now, if the needle recording electrode is placed over here, and the action potential propagates towards and then away from the needle electrode, the electrode is going to record that initial positive field followed by a negative field followed by a trailing positivity, and that's what is recorded as a triphasic positive potential. And so a fibrillation potential that's generated at one point of along the fiber with a needle electrode at a different point along the fiber will look triphasic, such as this. So there's a nice triphasic fib. Now, in a different situation where the needle electrode has either damaged the muscle fiber, it's compressed it, or the fiber has been damaged by disease, if that same action potential that's initiating right here propagates towards the needle electrode, it can't propagate past it. In essence, there's some type of kind of block of the electrical field, so the recording electrode will only record the initial positive field and maybe a bit of the negative field, and that's what it's recorded as a positive wave or a positive sharp wave, and it would look something like this. So the morphology again reflects where the recording electrode is in relation to where the fibrillation potential is being generated. And there are some instances where the recording electrode may move slightly, and what's initially recorded as a positive wave may change morphology, the same fibrillation, and become triphasic or vice versa. So in essence, the morphology doesn't necessarily reflect disease, although in some instances it may, but it reflects the relationship between the needle electrode and the site of generation of the fibrillation potential. So I think the take-home point is that while there may be some diseases or pathologic conditions where positive sharp waves are recorded more frequently than fibrillation potentials, both of them can occur in the same muscle fiber, in the same type of condition, and one can't make a diagnosis, a clinical diagnosis or an electrodiagnosis solely based on whether the fibrillation potentials are positive sharp waves or spike form fibrillations.